start the class with. Yesterday we discussed one thing. I said I will get back to you on that. Basically, the thing is, yesterday I asked whether the integer 3, if we compare with equal comparator with the float 3.0, we checked it's coming as true. But we didn't know why, right? That's why I said I will get back to you on that. So now the question comes, if I do 3 equals to the string of 3, what will I get? Why that injustice here? Different? These are different data type.
Actually, strings doesn't calculate as a number.
Sorry?
Number 3 doesn't calculate it as in string character. It is a character, not a number.
Okay. So the thing is, it's like the Python does a compatible check. Okay, compatible check, compatibility. If we see, mathematically 3 and 3.0 is same, right? But if we put inside a quotes, it completely becomes a string. It can't, unless we does the conversion, unless if we do int of 3, this will remain as a string only, right? So compatibility, there is a compatibility between int and float. Okay, so when we see this, mathematically these two are same values. That's why we get it as a true. Okay, so in Python, okay, in JavaScript, if we do 3 equals to 0, it will come as true. Okay, in JavaScript. But if we do 3 equals to 3.0, this will come as false. Because two different things is happening here. JavaScript, when we do this comparator, when we use this comparator, it will just check the value. Okay. When we use when we use this type of comparator, it will check value with the data type. This behavior is in JavaScript. But in Python, all it does is whether the value is equal or not, doesn't matter the data type. If you see, this is a different data type, this is a different data type, this is integer, this is float, still both are same. As based on the value, Python only checks the value. Okay, but if we do this, Python doesn't understand what is this unless you convert it. So that's why we get it as a false. Is it clear or? Okay. So today's class will be very important because most of the interview questions, especially the written test, will be asked based on the topic which we are going to discuss today. We are going to discuss advanced functions and file handling and exception handling. Okay. Before I get into advanced function, few things we must know. For example, how the memory allocation happens in Python. Okay. What is memory allocation? Can anyone answer? Allocating memory to? No, allocating memory to what? If you are saying variable, if you are saying data, if you are saying data type, okay, whatever. So when we write this, when we declare a variable a is equal to 10, we might have thought a variable, this is a variable, right? Variable is storing a value, which is a misconception. For a beginner, that explanation would be okay, but still in reality, variable doesn't store the value. That's a misconception. Variable stores the object reference. Okay, very important. Variable doesn't store the value, variable stores the object reference. So what is object reference?
Address of the value.
Yeah, louder.
Address of the value.
Address of value. Okay, this is the location where this particular value, the 10, is stored. This A will be pointing to that particular memory block. Okay, for example, this is my memory. Okay, let's say these many space are there. Basically in 8 GB memory, so many such blocks will be there. I'm assuming only 10 blocks are there for simplicity. When I say A equals to 10, what it does is, in one block 10 is stored. For this block, one address will be there. One address will be there. This A, the variable A, is pointing to that particular address. Okay. To know what is the address of that particular variable is pointing to, we have a keyword in Python called ID. If we do ID of any variable, we get the memory address. Okay, I'll show you for an example. A equals to 10. I'm printing the address of A. So this is how a typical address would look like. Basically it's returning in the integer format, if I'm not wrong. Yeah, it's returning in the integer format. Let's check the type of it. Yeah, it's returning in the integer format. Internally it might be storing in the hexadecimal or any other method. I don't care about it. The ID is returning. When I do ID of some variable, it's returning in the integer format. Okay. So this is the location. There will be many locations. This is the location where the value of 10 is stored, like this. Okay. So one more question I have for you guys: whether int data type is mutable or immutable? Int data type is mutable or immutable? One answer, mutable. Can you give any reason if you have anything in your mind? We can change the value. Okay. So that's a good reason. Basically what he is saying is, if the A value is 10, what is the meaning of mutability? We can change the value, right? He is saying if I do A equals to 10 plus 2, value of A is getting changed, right? That's the main meaning of mutability. But if I say, what if I say any other answers? Okay, technically he is correct, but still the way Python works is different. I'll show you. If I do A equals to A plus 3 and print ID of A, according to him the ID should be same, isn't it? Yes or no? Yes or no? Right? As you said, integer is a mutable object. For the same variable I have changed the value. According to you, if I do 10 plus, what is it? 10 plus 3, this should become 13. Correct? Then if I do ID of that, if I take the ID of that, I should get the same ID, right? Let's check if it is happening. Both are different IDs. Why? If integer is mutable, then why is this kind of behavior? Are you able to catch what I am saying?
Sir, because first A is allocated to different address and second updated A is allocated to different address.
Okay. What happened to the previous one?
It's not byproduct, it's still there.
Okay.
But if we execute that, if there is that location, we are updating anything, we get a new location for that.
Okay.
It is
So that means int is mutable or immutable? Say. Okay. Int is immutable. I'll repeat again what's happening here. First, when I did a is equals to 10, there will be so many memory blocks. In one of the block, value 10 is stored. For that particular block, one address will be there. For example, this address is 1, 2, 3, 4, 5. Continuous allocation will be there. I mean, continuous address naming will be there. 7, 8, 9, 10. Okay. Since in my laptop so many things are running, that's why you got some random number somewhere in the between in the memory. Okay. I'm assuming this is my memory. When I do a equals to 10, 10 will be stored in one of the block. For that block, one address will be there. In this case, address is 1. A is pointing to that particular address. Okay. When I did the ID of that particular variable, I got 1. Basically, in this case, the first ID. Later, I changed the value. Basically, I updated the value of that particular integer. Okay. This was the previous variable a equals to 10. Then I did a equals to a plus 3. Basically 10 plus 3. Now a became 13. Internally, what happens, for integer variable, as he said, 13 will be created somewhere else, and this pointer a will be pointing here. So that's why when I did address of a again after the updation, you got different address, because it's no more pointing to the same location, it's pointing to the different location. Any doubts in this? Any doubts? So the integer kind of behave like a immutable. It might look like mutable because a is 10. I am able to change the value of a, right? It's not throwing any error. If I do this for tuple, it will say no, you can't update the value in runtime. But here I am able to change the value. That's why he said it's a mutable. Technically he is correct, but internally this is how the behavior happens. When we change the value, a new location 13 will be stored in new location, and the a pointer will be pointing to that particular new location. The old value will be as it is. Nothing will be pointing to that. Should I repeat again? Anyone need any explanation? Because it's very important. This is only debugging. No. First point, we are assigning the value 10. Then I am printing it, printing the address of that. You mean this this feature? Sorry, I don't use debugging feature. You can try it. I don't use that debug. That's what you're saying. In left side it will be there, right? Debug and yeah. I don't use that feature. Not used to it. But you can try it. So what happens? Initially, I declared one value. I initialized one value to the variable. One allocation happens. Yeah. I am printing the ID of it. I got some random ID. Then again I change the same variable, updated the same variable. Then again I am printing it. Again I am printing it. I got different ID because 10 will be there in the same place. 13 will come in the new place. That A will be pointing to the yeah. so many places there in the file. Any doubts?
It is memory wasted.
Huh?
It is memory wasted.
It's kind of memory wastage only, but Python will take care of it.
I don't know how it is. Mobile phone will be developed based on some it is
Mobile?
mobile phone has storage. It is exceeds, then we have to delete something.
The deletion in the mobile phone and laptop happens how you know. For example, um, okay, some blocks will be like this. Okay, when you say this image, click on this image, that the location you see, right, that will be pointing to some memory location like this. When you delete, the content will be there only. Only pointer will be deleted. Storage will be there.
It is storage base will also be mobile like that.
You can check on it because let's say you have 4 space. Here image, video. Okay. Here some 10 GB data is there. Here some 10 GB data is there. Okay. When you delete this image, this 10 GB data will be there only. Just this pointer will be deleted. You can no more access to it. That's how internally it works.
If we save with the same file name, it will get that replace with the file name.
Coming.
You are saving any PDF, then if the file is already exist, you will tell that replace it again. So it will not wasted of memory. So you are changing A equal to 10 and A equal to 30. So you are giving the value to the same way. There will be wasted of memory.
That's what I'm saying.
How will it take care of finance?
Yeah, that's what I'm saying. The deletion, actual deletion, if you delete an image also, the image will be there only. Just the pointer will be deleted there. The pointer will be moved to recycle bin. If you delete there, even if you delete there, the actual content, your image still will be there in your device. That's how the forensics department works, right? There are few forensic tools. Even if you delete, unless you overwrite the value. For example, if you have 10 GB of images here, unless you bring new 10 GB of image, unless the override happens, the data will be there only. Using some forensics tool, we can extract that data. Even if you delete from the recycle bin also, data will be there. Okay. So just the pointer will be moved to somewhere else, or the pointer will be deleted. The content will be there. That's how the storage system works. And yeah, this is how. So the integer, we can say it's immutable. Why? Because when we give new value, when you update the value, the old address, the old value will be there as it like that only. The pointer will be moved to new place. That's why we see different address. And in the previous classes, I have said the list is mutable, right? So if I say I have a list 10, 20, 30, and this L will be having some address. If I append this, if I append 40, and if I take the address of L again, what will I get? Whether same or different? One answer different. Why?
The same. The existing address will be there, but it will create a new address for that new append one.
Okay, you saying it will work same as integer only. But Python works differently. For list, if you take the address before updation and after updation, it will be pointing to the same location only. Okay. We have few data types that are immutable. We have few data types that are mutable. We will discuss what are those. Okay. I will show for list. So as per my explanation, address of both should be same or different? Same, yeah. For list, both are pointing to the same because it is mutable. Okay, whichever is immutable, new location will be allocated in the memory, and variable will be pointing to the different one. So what are which are all mutable, which are all immutable? We'll discuss. In float, string, tuple or immutable. Okay. List, dictionary, what else? Set are mutable. If you update the value of this, tuple won't allow to update. If you update the value of this, it will be, new object will be created, new memory allocation happens, so that's why it's immutable. Mutable, even if you update, delete, doesn't matter, the pointer will be showing to the same location, so that's why it's mutable. Any doubts? Any doubts? Are you able to understand? You can check, you can declare any variable and check the ID of it, update the value of it, then again check the ID. If it is coming same, means immutable. No, if it is coming same, it's mutable. Coming different, A equals to both are coming same, it's mutable. Write this code. In this case, you should get different ID. In this case, you should get same ID. Mutable. Copy it's different. You will create in the new memory. Copy it. Method is there. That itself means that it will create in a new. It will create a copy clone of it. You update the same list, then check. The thing is, if you have a list, let's say 5 items is there. Change that list only. Check whether the address is same. I'm talking about the same list. You are taking the copy of it. This is the list. Okay. You are taking the idea. You got this idea. Taken the idea, you got the memory address of this particular list that is pointing to. Okay. Now you are taking the copy of it. That means data might be same, but internally it will be done into the memory, just like how the int variable behave. Variable is same only. The way copy behaves is different. It takes the clone of it and points to different location. Here, see, this list, new list, is a different list. It's not a old list anymore. It's itself a new object. It might look same for you, but internally you are creating a copy of it and giving the same name. Getting? No, it's kind of the same only. If you are changing the same list, then if it is pointing to the same list, then it's kind of mutable behavior. You can able to change the value. This completes itself creating the new clone. Does not matter if you have a old variable. I'll show you the code how it looks. I don't use debugging. See, it's very straightforward. I don't have a list. Change that list of list. It will be pointing to the same pattern. But I don't prefer this debugging. You should know line by line what happens. Yeah, that's what I was saying, right? Have a list. You are getting an address. Updated the list. Now you get the same address. Here debugging. I am pressing the statement itself for debugging. This is not same. If you are taking a copy, creating a new object. That's how Python behaves itself, right? That's why I don't prefer using debugging because I'm explaining, right? That's how it is. But I'm not comfortable using debugging. Because I prefer explaining the code. This is how internally memory allocation works. Line by line, we should know what is happening. We won't depend on the debugging tool. We won't learn it. Okay, this is what happening. Then I'm agreeing it. If I'm teaching line by line what is happening. It's kind of, if we are thinking it, right? We need to think it. The question should arise. See, what I'm saying is, whatever you show right now is same as how integer behaves. Variable might look same. The old values, this is how the memory will be, right? The old value is 10. A will be here. You update the value. A equals to A plus 3. 13 will come here. A won't be pointing to this address. A will be pointing here. It's whatever you show an example right now, it's exactly behaving the same way. See, copy itself creates a new thing. See, this is first list. you had 10, 20. Okay. Internally, it's like list 1. When you do copy of it, it will become listed 2. List 1 of copy. New list will be created. Both are two different things. Both are two different things. Both are again itself a mutable thing. Two different things you are talking about. Two different things will be pointing to two different location, right? You are not talking about single thing. Two things are there. Not getting. See, you had one list. You took a copy of it. It becomes two lists. This is list 1, list 2. Now you should. How can you say that list 1 and list 2 should point to the same address? No, that doesn't happen like that. Because you could have questioned the same here, right? For integer. Data is same, variable is same. Why it's creating the new address? Because Python itself is like that. You're getting? Those are two different things. Two different things can't point to the same address. You're creating a copy of it. Here I'm talking about the list 1. I'm appending to the same list. Yeah. Here copy is not happening. For the same list, one more element is getting added. That's why I'm talking about one single list. You are talking about two lists. That's why two address. Any doubts? Okay. Next. Yeah, to discuss this this concept, how the memory allocation happens. Memory allocation. This is very crucial importance in the concept called functions. Okay. In functions, we define a function. And it might be having some variable, some logic happens inside and it returns something. Okay? You call this function with some values. Okay? And whatever the value is returned by that function, you will store it here and maybe you can print it. Okay? Typical function behaves like this. This type of function is called positional argument. Okay, positional argument. So what is argument? What is parameters? There are two things: arguments versus parameters. Any idea? This is parameter. Okay, actually you said ulta. This is now this is parameter. Whatever we pass is argument. Okay, the value which we exactly pass in the function. When we call a function, we call it as a function call. Okay, function call. When we do the function call, the name, this name must exactly match with this. That, I mean, there will be so many functions. Whichever function we call, that function only will be triggered. Whatever value we pass, these are called arguments. The variables here in the function definition, this is called function definition. Okay. And this argument and parameter, we can sometimes use it interchangeably. I mean, it's not a big deal, not a big mistake. Sometimes we can say this is parameter, this argument, not an issue. but actually these are called argument. Whatever we pass, whatever declared in the function definition, that is called parameter. Okay, so when I do 2 comma 5 and in the parameter there is a comma b, this 2 is pointing to a, 5 is pointing to b. Basically first position, second position. Based on the position, number of positions should match. If there are 3 items here, 3 parameters should be there. 5, 5. So that kind of function is called, they are using positional arguments. Because position we are matching. When I do print a here, 2 will be printed. Okay. When I do print a here, I am calling this function. This 2 will be pointed, this a will be pointing to 2, b will be pointing to 5. If I do print a, I get 2. If I do print b, I get 5. So that's because we are using positional argument. Most probably we will be using this only, positional argument. There are other different type of functions. For example, if we want to explicitly tell a equals to, we can write like this, function a equals to 5, b equals to 10. Okay, when we are doing the function call. If a is here and b is here, now it's no more a positional argument. Whatever we are passing to this a will be taken for this. Doesn't matter what the position is. Whatever variable we are assigning to, that will be taken. As you can see, this is in the first position, but a here is in the second position. B is in the second position. Here it's in the first position. But still, if you do print b, you get the value 10. Getting? Let's code this. So this is kind of positional argument behavior. What we did? So this is a typical how the function will look like. Unless you call the function, the execution of this won't happen. Okay, you are calling this function. The name of this is matching here. That's why this function will be called. Whatever value is in the first place, A will take that. Second place, B will take that. These are arguments. These are parameters. If you do print A, you get 1. If you do print B, what you pass in the same place, 20. You did return A plus B. A plus B is 21. Whatever you return, that value is assigned to C. You print it, you get 21. Any doubts in this? nothing. Blueprint create right this one. Yeah. Light on. Any one light this side? This side. Can you turn on? Which one you can't say? That function. Okay, I will write in the. One second. Yeah. What error are you getting?
Passing single value,
Yeah.
then we are getting that D is not declared.
This is not declared.
Yeah.
That kind of behavior because we gave some default value to 10 but we didn't give anything to B.
B also.
Let's give something to B. Okay. Can anyone explain the execution? Can you try? Yeah.
We call def function, but first we
What's the first line of execution?
first line of execution C is equal to function 20.
Yeah, line number 50, right? Hey,
Line
switch on button.
Yeah. Line
One second,
number
one
50
second.
will execute first.
Check the character. Sure. No, it's not so much. Yeah, okay. Yeah, tell. First line of execution is line number 50.
Line number 50 will execute first.
Okay.
The value 20 is there. It will replace by 8 because it's the first value.
Yeah, right.
And the line number 44 will execute because we call the function in fifth number.
Yeah.
50. But then the 45 execution will happen, that will print 8, that's 20.
Yeah.
Then 46 will execute, that's 20.
Yeah.
Then
Why 46 line number is 20?
Because we declared as 20 in B.
Okay.
Then
Once again, let me change the value for confusion.
Then it will print 21 for A, and the print B it will print as 20. It's print as 21.
Yeah.
And it will come to the next line as a print slash, and that means it will skip line 1.
1 second. A plus B into C. Why is line number 51 is not executed? Is it executed? No. I should have, one second. One second. Yeah. Now.
After changing that slash, and so it will print, it will add the value of A and B. Then it will print the value of A and B.
So what is the value of A and B here?
Here A and B value is 21 and 20.
Okay.
And the sum of A is 41.
Yeah. Okay.
Then the next it will call again the quality function. It will go to next line because we have printed slash.
Yeah.
Then it will go to second function, that line 52. Again we call the function that we have changed the value as 5 and 25.
Yeah.
So the value of A is 5 now and B is 25.
Yeah.
Then we print A and B. So the value of A is 5 and B is 25.
Okay.
And the sum of A and B is 30. So again slash, again we are calling function.
Yeah.
And we have specifically declared as a B is 29.
Yeah.
So A value is remain 10 only and B value will change as 29.
Okay.
And the execution is same.
Yeah, correct. So here in the what is this type of called keyword argument, right? So no, default argument. Okay. Here we have explicitly give some default value to the parameters in the function definition. Unless we pass the value in the argument, it will take the default value, whatever there in the function definition. Okay. As you can see in the case number 1, when I do line number 49, when I do C is equal to function 21, value of A is replaced with 21, but value of B is still taken as 20 because we have given some default value, but we did not pass any argument, right? But it takes the default value. That's how the this default argument function will work. Any doubts in this? Try with different permutation combination, you will get to know. try it yourself, try with different combination, so that you might get some error or some clarity. You might get some clarity if you try different cases.
வேல்யூ இல்லைனா மட்டும்தான் இது போய் அங்கே அசைன் ஆகும். இப்போ அந்த வேல்யூ இருக்குல்ல, அப்போ அந்த டிஃபால்ட் ஃபங்க்ஷன் சி இருக்குல்ல, சேம் அதே தான் பிக்கு 20 அப்படியே நாளைக்கு எக்ஸ்டென்ஷன் அனுப்பிட்டா மாறிடுச்சு. கண்டிப்பாக எல்லாமே ஃபஸ்ட்டு 10க்கு மாறும். அப்புறம் வந்து வீக் அப்போ சிஏ நம்ம பிரிண்ட் பண்ணுறோம். ஏவோட வேல்யூ வந்து 21, பியோட வேல்யூ 28. அப்போ அந்த 21 இப்போ டிஃபால்ட் ஆகிட்டோம்னா நம்ம அந்த எந்த வேலையுமே அசைன் பண்ணணும்னா தானே அதை வந்து ஒர்க் பண்ணுவோம்.
இப்போது டிஃபால்ட் வேல்யூ நாங்கள் கொடுப்போம். இதில் கொஞ்சம் டெஃபினேஷனில் என்ன கொடுத்துருப்போம், 20 10 20 கொடுப்போம். இப்போது கால் பண்ணுவாங்க ஃபங்க்ஷனை, அப்போ எதுவும் வேல்யூ பாஸ் பண்ணலைன்னா இந்த டிஃபால்ட் வேல்யூ எடுத்துக்கிட்டு. இப்போது ஒரு கேஸ் நான் இப்போ காட்டுறேன் பாரு. இப்போது சி ஈக்குவல்ஸ் டு ஃபங்க் ஆஃப், நான் எதுவும் பாஸே பண்ணல, ஜஸ்ட் கால் பண்ணுறேன். இப்போ என்ன ஆகும்,
அந்த
டிஃபால்ட் வேல்யூ எடுத்து if I pass some value specific அந்த நியூ வேல்யூ சேஞ்ச் பண்ணுறேன். see last எதுவும் பாஸே பண்ணல, still I'm getting whatever the default value. Just quick recap guys, just keep on telling what output might we get. So here will we get same ID or different ID? Anyone same ID? Just line 1 to 5, that's it. Others are commented. Same ID or different ID?
Different ID.
Why?
Because integers.
We can say int as immutable kind of behavior. Okay. 1 second. So we got different ID, right? Okay. Next. Here, same or different? Same or different? Because list is mutable. Same ID. We are changing the same list, okay? Here only single list we are talking. So here, what do you think? No, here just what A will be printed.
1 and 2.
I'm putting one extra print statement here. Print ID of A. Print ID of A. So now tell me, ID of A and ID of B are same or different? Same. Anyone same? A is a list. B is pointing. So if I print the ID, will I get same ID or different ID? How many same? What do you think? Same. So here B is pointing to the same what A is pointing to, okay? Unless I'm not modifying B, I'm reassigning values to B. Unless I reassign the value, if I print A here after this statement and print B, and again if I print the IDs of those two things, so this is ID of A, this is ID of B. Both are same because they are pointing to the same thing. Okay. Next print statement is ID of A. Again the same thing. It did not change. But B, we reassigned B. That's why that new values is stored in some other memory location. If I print the address of B, I will get different one. Okay. B is not pointing anymore to the A. It's pointing to the different. I did give new values to the B. Okay. So A will be the same, B is new. And if I do print B here, what do I get? Print B.
The value of A.
Yeah.
Value of A.
Yeah. Whatever it's pointing to, we get the same thing. Okay. Any confusion in this block? Because very important in interview, written test, they might ask this. Any confusion in this? Yeah. Sorry? You did not understand. Okay. No, so explain to you. Yesterday I did not explain to you. Yeah, I will explain one more time. Listen, this is a memory blocks, okay? When you do A equals to 10, variable doesn't store values, it stores object reference. Okay? When you do 10 will be stored here. For this block, one address will be there. To find out what is the address, use the method called ID. Okay? If you do ID of A, you will get some integer address. That's a memory location. A will be pointing to this location. Okay, this is variable. When you modify the value, A equals to A plus 3. What is the previous A value? 10. 10 plus 3, 13. You might think 10 will be overwritten by 13. This doesn't happen. Okay, because int kind of behave like a immutable. 10 will be there only, 13 will come here. This A won't point to this location anymore, will point to this location. Address also changes. So that kind of behavior will happen for int string, float, bool, tuple. Okay. Others are list. These are immutable. You might think that we can change the value, we are able to update it, right? But internally new location is created. Okay. So it's kind of immutable behavior. List and set dictionary. These are all mutable. If you do the same, for example, if you have a list A equals to 1, 2, 3. So take the address of this, you get some value 100, something like that you get. You append the value A dot append or A dot pop, something you do. For example 10. What happens? New A will be 1, 2, 3 and 10. Right? If you again take the address of A, it won't create a new copy unless you do. Okay? This A will be pointing to the same address, you will get 100 on it again. So for these many things, address won't change. For these many things, if you modify, address will change. Okay. I hope this is clear, right? Sorry. Before this, let's do this. Try this, anyone? Can anyone try? We get 5. Okay. Why not? What happens inside? We pass 5, which will become okay. If I print here.
Now I have to
This is very classical interview question. Okay. So execution starts here. Line number 41. So value of A will be value of A is 5 and we pass the value of, let's say 5 is here, A is pointing here. Okay. We call the function modify A. We pass value 5 inside the modify function. The modify function, what it does, it takes the value 5. Now x is also pointing to yeah. X is also pointing to 5. Okay. When I do x is equal to x plus 10. As I said, integer is kind of immutable behavior. What happens? What is the value of x now?
5.
5 plus 10? 15. X will create a new memory block. Okay. So x is not pointing to this anymore. New thing will be created because as I said, integer is kind of immutable behavior. And one more thing, this is very important. In many programming language, function behaves differently. Okay? In few programming language, it might support pass by value, pass by reference, pass by address. Okay? But in Python, we pass the value by pass by object. This is a kind of way Python is developed. We are not passing the value, we are not passing the address, we are not passing the reference. To be specific, we are passing object reference. Okay. I passed A, I modified it inside, but still A is unaffected because new place is created for X, and if I print outside A, what happens? I get this value only. It won't modify. What happens if I print X here? What happens if I print X in line number 45?
Sir, it's a variable is not declared.
Yeah, because it's out of scope, right? Because X will be, X is known only in this place. Yeah. So X is not, that program can't access X in that place. So the answer of A will be 5. But in contrast, if I pass the list there and modify the list inside the function, and if I print it outside, what happens?
It will modify. Change value.
What I am doing is, I have a function, modify, will take a list, appending the list and modifying it, appending the value 50. That's it, I am doing nothing else. While I am calling, I have a list here. Passing list, therefore printing it. What will I get? Will I get 1020 or 1020 50? Two possible answers. What we might get? 10 20 50. Because in Python we do pass by object reference. As I said, integer, if I change the value, and if I ask, if I print the same value, what, I mean, if you want this updated value in this function, what can we do? If we want 15, what we should do? I pass 5. I want to that value 10 to be added. Okay. As a result, I want the answer. If I do print A, I get 5 only, but I want 15. What should I do?
You have to write global keyword.
Huh?
Global keyword you have to write there.
Global keyword. Yeah, that works, but that's not preferred. Any other? If I want 15, if I pass 10, I want 20. If I pass 25, I want 35. I want 35 here. If I pass 25, I want 35 here. What we should do? If I print here, I get the same old value. What's the use then?
Change it to list.
Huh?
Change it to list.
Change it to?
Yeah, the A will change A as A is equal to list, private list.
What can we do? We can just return the value, right?
Can you assign the value in A if I modify equals to inside the A?
Inside only if I do A. Let's try that. We don't know. So you're saying this situation, right? Right?
Sir, I just told him modify you can change down there, sir. So it's the A, right, sir?
Yeah, yeah.
Yeah. Where if we add equals to 1, if we add 35 or whatever the number is, we get
second. Yes. You said we'll use list. List is okay. But my question is, so we have what I did. I got this is the first line of execution. A 5. I pass 5 inside modify function. Inside 10 is added. So inside A 15 comes here. But if I do print again, if I am accessing A, I'm getting 5 only. I'm not getting the updated value. If I want updated value, what should I do? Then why are we using function? I need updated value. What should I do? Yeah, we just return. That's it.
That's it.
Yeah. We'll just return whatever we have inside and let's store it in the variable. That's it. So if you want the result, okay, function is used for two things, okay, especially in backend development. Function is used in two purpose are there. One is do something, task, and return value. I might use this value in the further logic, okay. Second, just to do the task. Can you give an example for second one? Just do the task. I don't want anything from you. This is the task you should do. I'm calling you. That means you should do this task, and that's it. I won't bother about it. Just do the task. Any situation. Yeah. The proper function is two things. One is I'm calling it. I give some value. Do this. Return the new value. I will use that value later. Second is just to look the code cleaner. I will write the task in the function and give it somewhere. I will call it to do the task. That's it. I don't want your value. Any such example?
Like creating a class inside that class to create a def function.
Yeah, I mean, give one real world example. Like, just do the task. I don't want the value from it. So, typically what we do is, for example, when user logins, we take phone number and we take phone number. First we'll check whether this user exists or not. Let's say if the user exists for login purpose, I call a function that will send the OTP. I just call this function. That's it. I don't want anything returned from that. This function will be sending the OTP to the user's phone. Right? I'm not expecting anything from this function. So this kind of application this is one of the purpose where we use a function. I'm not giving any value. I'm not taking any value. I'm just saying do this task. That's it. Okay. Example: send the OTP to the phone.
Just for verification purpose.
Send. I might want true or false, right? After that, logic something. Here I'm just saying send the OTP. That's it. Or send some mass announcement. Understand? I don't want anything from the function. I don't want it to return. It's not mandatory to return. Okay. It's not mandatory to return. Write that return statement. So now the question comes: if I pass integer and if I pass the integer and if I do something inside, if I add 10 to it, or if I take a square of it, and if I don't return, if I access the same variable name, I get the old value only. That's the case for integer, but for list and other mutable objects, it's different. I have a list like this. I call the function to modify. What it does, it adds 50 to it, and if I don't return also here, if I just print that variable, I get the updated ones. Let's check it. Yeah, any doubts? See, I'm not returning anything. I'm just accessing that variable after modification. I'm able to get the updated ones because it's mutable. Yeah. One last concept in advanced function. This is very important in terms of Django. Args and keyword args. When I say args, I'm saying argument. KW is keyword argument. So this is not like a mandatory keyword. This is mandatory. Okay, this star and this double star. Okay, doesn't matter whatever you write here. So this star is a main thing. Okay. So if you want to pass the list, and if you don't know proper position, number of positions, how many positions you have, you can use this in the function definition. For example, if one args. Okay. For example, if you want to take the sum of this list, what do you get? And keyword arguments. This is nothing but a list. Okay, how do we call this? I have a font like this. So here no position, no default value, no what else? No keyword also. I'm just passing a list. I'm doing something with that list. So here I'm doing the sum of it. Or if I want to ask the maximum element out of it or minimum element, whatever. This is kind of list. So I'm passing n number of values. Doesn't matter. I can pass one more value inside this. Doesn't matter. So if you are using this kind of situation, then we use star args in the function definition. When I say keyword argument, while calling the function, I have to mention the keyword. This is very important. Comma age. Okay, and even in this, there is no number of limitations. You can give n number of arguments inside. That's a speciality of location value. Okay, you can give n number of. The thing is, it will behave like a dictionary. In this it will behave like a list. In this it will behave like a dictionary because we have a key, we have a value. Then function start print. You can access this just like a dictionary. Print. Try this. Two different ones. Any doubts? When you are not sure about how much to pass, you want to pass a list kind of element, you can use star args. Okay. Any name you can give here, doesn't matter, but star is important. And you can access it like this. It will act like a list. To be specific, it's a tuple. You can iterate it through the loops. All kind of behavior. This sum is a built-in function. Okay. Built-in function. Yeah, this is working, right? How to access the value of dictionary?
Key.
Using get method or key, right? Get method is preferred. Any doubts? Because we use this very often. Everywhere we use this keyword arguments. Any doubts?